A spin is caused by two primary factors: the aircraft at or beyond the stall angle of attack, plus roll or yaw or side slip acting on the aircraft. A spin is divided into phases: incipient and fully developed. The incipient phase is that portion after stall when the aircraft commences a spin-like motion. The aerodynamic and the inertial forces have not yet achieved a balance. In the fully developed phase, the aerodynamic and the inertial forces are in balance, and the attitude, angles, and motions tend to be essentially repetitive from turn to turn. The view is generally a steep nose-down attitude with a yawing rolling motion about the spin axis. The airspeed is usually near stall. An angle of attack indicator would show a fully stalled condition. A light or horn will be activated by the stall warning system. The turn needle is fully deflected in the direction of the spin, and the rate of descent is significant. The gravity force acting on a spinning aircraft is essentially 1G. The spin is a recoverable maneuver in aircraft approved for spinning, but the recovery does require altitude. Weight, lift, thrust, and drag are terms that are familiar to you. You also know the rotation about the three axes of flight: roll, pitch, and yaw. To understand a spin, there are some other terms that you should be familiar with. Relative wind is the direction of airflow with respect to the wing as it moves through the air. Angle of attack, the angle formed by the relative wind and the chord line of the wing. Coefficient of lift, a numerical representation of the lift generated by a particular wing at a given angle of attack. Coefficient of drag, a number representing drag and derived from the same factor, angle of attack. Let's look at lift. As angle of attack increases, lift also increases. When angle of attack reaches a certain point, the airflow begins to separate from the wing. As angle of attack continues to increase, lift is still generated, but the airflow cannot follow the curvature of the wing. The stall occurs at the point of maximum lift. Drag also increases as angle of attack increases. Beyond the stall point, however, drag increases rapidly. When you are beyond stall angle of attack, if the aircraft experiences any roll, the upgoing or outboard wing would experience a decrease in angle of attack. Conversely, the downgoing or inboard wing has an increased angle of attack. The difference in angles of attack results in difference of lift and drag for the two surfaces. The upgoing wing is less stalled, and the downgoing wing more stalled. This differential condition causes a rolling and yawing tendency at angles of attack beyond stall. The tendency is called auto-rotation, is self-feeding, and leads to a spin.